was it recording there? This is on page 709. So they do the same thing with, normally if you had something like deer, if all 4 letters were different, it would be 4 factorial. But since there's 2 e's that are the same, we divide by 2 factorial and get 12. If you had geese, normally you would have 5 factorial, but because the 3 e's are the same, we have to divide by 3 factorial and get 20. So if you had a crazy word, and sometimes I call these Mississippi questions, because that's such a fun word with all the S's and all the I's. If it was Mississippi and you decided I like the word Mississippi, I'm going to make my password for my computer Mississippi and just rearrange the letters. Well, if all the letters were different, we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. That would normally be 11 factorial. But you have identical letters. You have 4 I's, so you would have to divide by 4 factorial. You have 4 S's, you'd have to divide by 4 factorial again. And you have 2 P's, you'd have to divide by 2 factorial. If you wanted those M as 1 factorial, you could, but that's redundant, doesn't need to be there. And so the number of ways that we could take something like Mississippi and rearrange them looks like this. Now, if we type that into our calculator and see what that number is, I'm not going to ask you to list them all out. $34,650. And if we think about where we started in this unit with counting, right? Counting is easy, but this is like a complicated thing to count. How many ways can you rearrange the letters of Mississippi into different passwords? If you decided my strategy was going to list them all, there's 34,650. That strategy would not be a very good strategy, because most likely you would forget some, and very hard to count them all together in the end. But now we have a strategy. If there's things that are identical, and it's called permutations of identical objects. If you have identical objects, you divide to get rid of that repetition. So what you're really doing is you're counting it like they were all different. So if there's Pee-wee, you'd start with 6 letters, which is 6 factorial. Then you say, but if I listed all 720 of them, there'd be a bunch of ones that the E's are the same. How many ways can you rearrange 4 E's? That's 4 factorial ways, which is 24. And when you divide, you would only get 30 permutations. So now this is strategy number 2. Strategy number 1 that we've had so far was just spaces. And our permutations formula was also just spaces. So now we have, when we read a question, we also have to think, are there identical objects in this question? Because if there are, I might have to divide. So we'll look at example 1. You go into the pantry of your house and you have 7 boxes of cereal. 5 boxes are bran cereal, 1 box is puffed wheat, and the other box is granola. And you will decide, I want to rearrange these so it looks really nice in my pantry. How many different ways can you rearrange the boxes of cereal? How do we recognize this as an identical objects question? How do we make this like a Mississippi question? So we could say, well, I have 5 boxes of bran, 1 box of puffed wheat, and another of granola. Do we have identical objects? Yes. So this is like rearranging the word Mississippi, except this time the word that we have is And so someone asks you, how many ways could you rearrange the letters of the word then you would say, well, normally I would have 7 letters, which is 7 factorial, but I have identical objects, which is 5 factorial. Now we're assuming in this question that all the brand cereal is different. It's not like you have a big box of brand cereal, and then Kellogg's brand, and Post brand, and No Name brand, and President's Choice. You could technically have different kinds, right? But in this case, we're assuming that those boxes are all the same. So then you do 7 factorial divided by 5 factorial. Can you do this mental math in your head? What is the answer? Some of these will be on the non-calculator part of your test, so you'd have to do this non-calculator. 42. I'm hoping you didn't do 7 factorial in your head and get 5,040 and then have to divide that by 120 and say, I know my 5,040 times table and get 42. Instead, you said, how do you simplify factorials? Start expanding the bigger one. And if I expand the bigger one, I'm like, when I get to 5, I could keep going, but I'm going to add an exclamation mark because that would simplify these away. And I think 7 times 6 is fair for mental math, non-calc. And you would get 42. Questions for practice on this one are 3, 4, 5, and 6. So circle 3, 4, 5, and 6.